Hello students, today we're going to solve another cylindrical component example. That will be our example 3. In this example we're going to use a water sprinkler. So let's see our problem. Our learning objective is to solve a curvilinear motion problem that includes cylindrical components, and in this example 3 we will apply the polar coordinate system to determine the components and magnitude of velocity and acceleration. Like I said, we're gonna use a water sprinkler in our problem. You might have seen the water sprinkler in your front yard or backyard. It also can be used in to water the field. So let's see the problem. So in this problem says from a sprinkler, water hits the fence. So the sprinkler is 10 meter away, which is located 10 meter away from the fence. So the sprinkler is just 10 meter away from the fence. If the sprinkler rotates, so the sprinkler rotates at theta dot pi radian per second. So d theta over dt is pi radian per second. The question asked is determine the velocity and acceleration of water hitting the fence at t equals to 0.17 second, starting from theta equals to 0 and r equals to 10. So let's find our knowns. We know that theta dot, the rate of the sprinkler rotating is given, and r cost at 0 degree starting point is 10 meter. We're gonna explain this part a little bit. Unknowns are at t equals to 0.17 second. Find the velocity and acceleration. So let's draw the diagram. So by the problem, the diagram says if this theta is 0, right? So the r falls on this line. So that's why r cos theta equals to 10 meter. Now let's start our solution. So first step to find the solution is to connect the given with the unknowns. So we know the vector form of velocity and acceleration. This is our equation. So if we can find these components, then we can find the magnitude of velocity and acceleration. Before that, we need to find, from the problem we see, we need to find the r dot, r theta dot, which is given, r double dot, r theta dot square, r theta double dot, r dot, this. So this is a easy problem once we figure out how to find this, and then we'll just plug those values into these two equations and it will be solved. So let's find the derivatives. So first r, we use trigonometry. So we know cos theta equals to this base, which is 10 meter, divided by this arm, which is r. So r equals to 10 over cos theta, right? So which gives an 1 over cos theta equals to sec theta. So that's how we get 10 sec theta. Now let's start finding derivative. So we know by law the derivative of sec theta is sec theta tan theta. Tan remains the same, and since r is the derivative with respect to time, so we need to add this, which means d theta over dt. This is comes because the variable and then the derivative with respect to t is not the same, so we have to add this. Now let's find the r double dot, which is a little bit complex. Now I'm gonna say how to get there. We again apply the chain rule to find the r double dot. So the 10 is constant, remains same. For sec theta, we got the derivative sec theta tan theta, and since the theta is not, and t, the derivative with respect to t is not the same, so we got theta dot, and tan theta, and theta dot remains the same as the first term. Now for the second one, the second term would be this term 10 sec theta remains the same. We have to deal with tan theta, and tan theta, if you take derivative, you get sec squared theta, and for theta you will get theta dot, which this one, and then this theta dot remains as is. And for the third term, we're gonna keep the 10 sec theta tan theta same, and for theta dot we'll take derivative. It gives us theta double derivative. So, and also we find, when we find the theta double derivative, we know theta dot is pi. So if we take theta double dot, which is constant, so it gives you 0. So theta double dot is 0. So we have found our equations. Now if we plug the value, we can find the values of this. So the question asks what would be the velocity and acceleration at t equals to 0.17 seconds. So we need to find those values at 0.17 seconds. So at t equals to 0.17 second, r is 10 sec theta. For we are working in degree, so I replace pi with 180, and the time is the same, so the 0.17. So that gives us r. This is this r. So the r first at theta equals to 0, the r was 10, right? Now over 0.17 second, it moved here. So now the distance from a sprinkler to wall, from sprinkler to wall increased. So this r is 11.62 meter. Now r dot, we just have to plug these values. So r dot is 10 sec theta tan theta. So if you multiply 180 to 0.17, that is 30.6. So I just plug these values, 10 sec theta tan theta, and pi. Theta dot is pi, so 3.1416. So that gives me r dot. And r double dot, we plug the same value as is into the previous equation, and we plug those values. The summation would be 194.86. So once we have this, now the problem is very easy. Plug those values of r dot and r theta dot, and we'll get the velocity. And if we take the square root of the first term and the second term, and then we get the velocity, 42.4 meter per second. So what is the direction? We know the velocity is tangent. So the direction of the velocity will be this direction, velocity v, and its radial component would be the same as parallel of this. So this direction, vr, radial component, and in 90 degree from here, it will be your v theta. So what will be this angle? It will be the same as this theta. Okay, so this is the direction of the velocity, and for acceleration it will be almost the same. So once we plug those values, we get the total velocity. Now let's move to the acceleration. Again, same way, you plug those values of r double dot, r theta dot is whole square, So plug these values, and for theta double dot, which is 0, so that gives you 0, and the remaining part, which gives me this. And as the radial component and theta component, if we take square root of those terms, and we get the acceleration, which is 88.08 meter per second square. Again, the direction of acceleration would be the same as velocity, acceleration direction, and the radial component would be this, parallel to this, which is AR, and again 90 degree of that would be the A theta, and this angle is the same as this theta. So this is the angle, and we know theta is here is 30.6. So we have found our magnitude and velocity. So we have solved the problem. In next, we're gonna study the next chapter, which is dependent motion. And see you then. Thank you.